Okay, what I'm going to show you is an experiment to look at how light behaves when it goes into different transparent materials. So the kind of equipment I'm going to use, I've got a ray box. Okay, what this does is it produces light for me. At the moment, because the light is thick, I'd find it really difficult to actually take any measurements. So what I've also got is a slit. What the slit does is let light through the little gap in the middle. So if I put that in there, you should be able to see I've now got a nice piece of beam. Because the light here is quite bright, it's making the camera look a little bit strange. So what I'm going to do is just cover that up so you can see the light a little bit better. Okay. So what we're going to look at is we're going to look at how light behaves when it goes through two different materials. I've got material here. This one's Perspex. And I've got another identical block, okay, almost the same size, that is glass. So you should be able to hear the difference between the two there. Okay, so the next thing I need is I need a protractor. So the protractor is there so that I can measure angles accurately when I'm looking at how the light changes from the angle when it goes in to the angle when it comes out. Okay, so I'm going to start with the glass block. Okay, so the glass block is bending the light as it goes in. So what I'm trying to do is investigate how the light going in here is related to the way the light travels across the block. Okay, so I'm going to need to draw some lines on my paper to give me a guide of how I'm going to do that. Okay, so I'm going to use my straight edge and I'm going to draw a line across the page. Okay, so that line in green is going to be where I measure to. Okay, so that's going to be called the normal. I'm also going to mark where I'm going to put my block. So the way I'm going to do that is I'm going to make sure that the line for where my block is at right angles to the line. Okay, so this edge, this line of the edge is parallel to this line. So if I draw a line here, that's where I'm going to put my block. So I'm going to start with glass. I put my glass block there, and now I can shine light in so it hits at that point there that I'm pointing at. Okay, I'm also going to mark the other edge. Okay, so perfectly lined up, holding in place, and I'm going to mark this edge. Okay, because what that does for me is allows me to work out where the light is going as it comes in this end and comes out that end. Okay, so what I'm now going to do is going to mark where I'm going to shine my first beam of light. So what I'm going to do is put the protractor on, and as you can see, it's perfectly square, and I'm going to choose my first angle. So I'm going to measure from the normal line to where I want to be. So my first angle I'm going to measure is 20 degrees, which is there. And I'm only going to do 20 degrees for the first experiment, and then I'll show you that you could do 30, 40, 50, 60. Okay, but we're going to start with this line. So what I'm going to do is take where I put my mark and join it to the cross to show me where I'm going to point my light. I put my glass block back on. I move my lamp so that it's now going exactly along the line. What I'm trying to do is get the line to be the middle of the beam of light that you can see all the way down. So I'm going to move it sideways a little bit, and I'm going to rotate. So I think that is about as close as I'm going to be able to get it. Okay. So what I'm now going to do is over on this side, I'm going to mark where the light's coming out. I can't just put the protractor there because that's not very accurate. So what I'm going to try and do is I'm going to try and draw crosses in the middle of the light. Okay, so there's my first cross, as close to the middle as I can make it. There's my second cross, as close to the middle as I can make it. And then here is my third cross. Okay, So I know that if I now join these lines up and move it back to this line, the side of the block, I know that's where the light came out. So what I'm going to do is get my straight edge again. I'm going to line up the crosses, and as you can see, they do line up quite well. And then I'm going to move my line until it gets to the block. Okay, so these are called construction lines. But what I've now got is I've now got a line to show me how the light went from here to here. Because you have to move through in a straight line through the block, so I can join those two things together like that. I'm going to carry that on a little bit. You'll see why in a minute. But that's where it would have gone if the block had carried on going. Okay, so now I need to measure some angles. So I knew that that angle here was 20. So that angle there is 20 degrees. I can already see that this angle here is smaller than this angle. So let's quickly measure that. Again, I would line my protractor up so it's exactly on the T is exactly on where the line goes. And now I need to measure this angle here. So there's 10, there's 15. So this must be 13.5 degrees. Okay, so let's just quickly write that down. I've got the angle of incidence, I've got the angle of refraction, which is this angle here. So I've got 20 and I've got 13.5. Okay, these are both going to be in degrees. Okay, I'm going to do the same thing again. Instead of using 20, I'm going to use 30, 40, 50. So I'm going to use the 50. Okay, so I join my line again. And now I'm going to see where the light comes out on the block. Because it's bending, it's actually going to come out a little bit further down the line, which is going to be quite handy for me. So I put my glass back on. I take my beam of light and I shine it exactly down the line. So again, I've got to try and make it so it's exactly in the middle. Okay, it's there. And now my light's coming out over here, look. So I'm going to put my X's on again. Okay, so a little bit harder this time because it's a little bit fainter because it's actually travelled through more glass. Okay, again, move my light source out of the way. Take the X's, join the line back. So the light this time has gone from here to here. So again, I'll draw my line on. And this time I've got a line missing. I haven't got my normal. So what I'm going to need to do is draw my new normal on. So I put that along the end, along the line, nice and neatly, at 90 degrees. And I draw my new normal on. Okay, so I'm now going to measure this angle and this angle. Okay, as I did before, but you should have realised why now, is I'm going to make this line go a little bit further, just to give me some room on the protractor for when I want to try and measure the angle. So I know that this angle was 20, 30, 40, 50, so this angle is 50. So it's 50 degrees. So this angle now, I've got to measure this one. So I'm going to put my protractor there, line it up again with the normal. My new line is going this direction. So it's going over to here, and that is 20 is here, so that is 25, that is 30. So this makes this 29. So this angle here is 29 degrees. So let's put that there. Okay, so as the angle got bigger, the angle that it was bending got bigger too. So the bigger the angle going in, the bigger the angle that it gets bent by. Okay, so if I now put perspex over the top, okay, and do exactly the same thing, let's see where the lines go for the perspex. Let's turn the beam back on, exactly line it up, which is there. And now you should be able to see that the light is actually coming out over here. Okay, so let's just quickly get the right lighting. So there you can go. You see how the light is coming out over here now? It's not quite the same angle, but close. Okay, when I move to 50, I get a similar angle, but it's actually slightly farther away. Okay, so the Perspex block is bending light slightly differently, it's ever so slightly differently to the glass block. So there's the glass, look. Here's the Perspex. Okay, not quite the same line. Okay, so what I've done is I've done the experiment, and I've done the angle of incidence between 0 and 80. I haven't done up to 90 because 90 degrees is directly along the side of the block. You can see there, and that wouldn't work. So I've done the experiment for glass, and I've done the experiment for Perspex. As you can see from the glass and Perspex results, they're very similar. Okay, so this is one of the reasons we can use Perspex instead of glass in windows. Okay, so if we look at the results, as I increase the angle of incidence on the graph, you can see that the angle of refraction is increasing as well. It's not a straight line, it's a curve. Okay, so that curve shows me that both the glass block and the Perspex are behaving in the same way. So the curve must have something to do with the way refraction works. So if we look at the results in depth, we've got the angle of incidence and we've got the angle of refraction. Okay, so the angle of refraction is always smaller than the angle of incidence. Okay, so what we can say is that the angle of refraction is always smaller than the angle of incidence. So if we trace the line continuing on, if you watch where my cursor is going, as you can see, it will continue down here if the glass block hadn't been there. So the light would have gone here. As it hit the surface, it's bent away from where it was going. It's bent towards this dotted line, which is representing the normal. So the angle coming in always bends towards the normal. So it must be something happening at the interface, because everywhere else it's a straight line. It's a straight line before it comes in, it's a straight line before it comes out. When it comes out, you should be able to see that it's doing the exact opposite. So instead of bending towards the normal, so the normal would be here, it's bending away from the normal. So it must be something to do with the difference between air and the material and the solid material is traveling through. We'll look at that in the theory. Okay, so if you look at the red lightsaber through both blocks, you should be able to see that it looks like it's going in a straight line. So both blocks are bending the light in the same way. Okay, so it shows me that the Perspex and the glass are doing the same thing. You can't see through the Perspex as well because this Perspex is a lot easier to scratch. So the Perspex just has a lot more scratches on it than the glass does.